So, first step was to train the learning. Next step was to add domain knowledge. Now, the third step is to actually use the model to do something useful. So one way to use it, because there are many other ways, is to say, I have the 10,001 patient who is 37 years old, 85 kilograms heavy, and is a heavy smoker. What is likelihood in the next 10 years to get CHD? Again, based now on the model. So let me now try to decipher for you this picture. Okay. Let's start from age. 37 years old, and this is a histogram of ages that were in this sample, takes you into this percentage. And based on that, you have 40% probability of a CHD. The heavy case takes you in a particular population in the smokers. And this produces a 30% chance of CHD. And by the way, weight places you into this population, so you're pretty much, as you can see here, more on the average, but that's 10%. So together, 4 plus 10 plus 30, it is 70%, and that's your total risk, or the probability to have CHD.
80%.
80%, I'm sorry, yes. Good. So your probability to get CHD, in this case, it's 80%. And at the same time, I can explain you how the model actually computed that.
Yeah.
So here, for example, you will say, oh, it's only 10% the contribution of the weight, and only 30% is the contribution of smoking, and why is 40% contribution of age? By the way, intentionally I put those numbers there to illustrate to you that based on this sample, this is the conclusions you get.
Yeah.
Okay? And those conclusions could be contrary to your belief. And there may be some reasons for that. Either the sample is distorted, okay, or perhaps our system is not correct, and we have to correct that if that's the case. Or maybe the modifications we did to the model previously made it produce this number. But you can trace your way back, because you can look at how this was produced.